Hello, Professor, GSI, and everyone. We are Group 13 and I'm Yu Chen, along with Jim, Yu Chen, Teddy, Santiago, and Lucas. Today we are going to take a brief view of analysis and redesign of the boosted electric skateboard. So, there are two targeted customer groups of our product. The primary customer group is skateboard hobbyists who enjoy the speed of electric skateboards. Unlike traditional skateboards, the electric power system eliminates the need to push the skateboards forward with foot and increases the upper limit for speed. And the secondary customer group is students or working adults who commute daily in cities. The probability and ability to travel on sidewalks and roads make electric skateboards the ideal choice to save commuting time. This is the exploded view of a traditional electric skateboard. There are three main parts in it: the front trunk part, the power system, and drivetrain system. For front trunk, wheels and bearings are attached to front riser. For subassembly 1, it's a power system that main battery is covered by a battery case and connect to motor in drivetrain system. For subassembly 2, wheel pulleys are first inserted in motor mount. Following is the insertion of motors and belts, and then attach wheels into motor mount. After that, subassembly 2 was installed onto the back riser. Finally, three main parts are secured with 4 screws each onto the deck.
As shown in the fast diagram, the electric skateboard's task function is to transport the user, with two branching basic functions: control speed and control direction. Each basic function is then divided into two supporting functions. In order to control speed, the electric skateboard must be able to increase and decrease velocity. And in order to control the direction, the skateboard must allow the user to distribute weight while providing enough grip to maintain balance. Other supporting functions include assure dependability, assure convenience, enhance products, and please senses. Assure convenience is further branched into two functions: ensure portability and reduce travel time. The diagram below shows the first possible assembly sequence of the electric skateboard. The sequence includes two subassemblies: the drivetrain system and the power system. The assembly begins with the deck and connects each subassemblies once they are completed. This is the second possible assembly sequence. While this sequence also begins with the deck, the order of the trucks and risers have been moved forward in the process. This reduces the complexity and facilitates the drivetrain system subassembly. The table below shows the scores of each assembly sequence in the respective criterion. As the scores indicate, Sequence 2 has the highest score in both ease of transferring and handling and ease of locating parts, making Sequence 2 the better assembly sequence.
This is the function component mapping matrix for our electric skateboard, which shows which parts correlate to which functions. The front and back risers will help the customer shift weight without the deck of the board hitting the wheels. They should also not be too large in order to keep the board height small to ensure portability. The trucks will affect the skateboard's ability to turn, shift weight, and the balance of the user. The wheels will help the user maintain balance depending on their size, which will also affect portability because we want the board to be relatively small. Wheels also help the board go fast and thus reduce travel time. The bearings will ensure that the wheels and trucks are secure and won't wobble, making sure the user maintains balance. The motor and the pulleys of the board all have a role in powering the skateboard, which means controlling speed and increasing and decreasing velocity are affected. Because they power the board to get fast, they also help reduce travel time for the user. The motor must also be small to ensure portability. The batteries of the board will power the motor to increase velocity of the board, which helps reduce travel time. The motor casing mount and the battery casing will keep the motor and battery compact to ensure portability. And the deck will allow the user to control direction and shift their weight. And the size of the deck will also affect the portability of the skateboard.
The bill of materials for the electric skateboard has a total of 16 parts, divided into 2 subcategories or assemblies based off of their functions: motor and drivetrain related components and non-motorized components. This separation also helps to distinguish them between the stock skateboard pieces that are ready to buy and the more custom redesigned components. The main materials used in our product are plywood for the deck, ABS plastic for the base plates, plain carbon steel for the tougher components, and polyurethane for the wheels. Plain carbon steel and polyurethane are somewhat standard materials for skateboards, each providing the proper amount of rigidity and durability for their respective components. We chose ABS plastic for the base plates since ABS is relatively cheap and still holds up well against small potential damages.
The parts listed in the bill of materials use a variety of manufacturing techniques. These include injection molding for the ABS pieces, die casting for some steel parts, and CNC machining for the geometrically simple steel parts, such as the motor mount and clamp. The rest of the parts, such as the motors, fasteners, and the wheels, can be made to order. Formulas learned from lecture were used to calculate material, processing, assembling, and tooling costs. For material costs, reasonable engineering judgment was used to estimate the scrap mass created by each part. For the component masses, we were able to pull directly from our full CAD model of the skateboard. For processing and assembly costs, we made a few simplifying assumptions, such as the US labor rate and average cost of CNC machines. Ultimately, we were able to reach a rough total estimate, with big headroom for improvement, at $555 for production costs for the entire electric-powered longboard.
Here we have 2 tables for the product family design. The top table divides all the functions into 2 groups: functions that will be the same for both customer groups and functions that will be different for each customer group. Looking at what will be the same for both groups, we don't want any customers falling off the board and getting hurt, so maintaining balance is a function of the board that should be the same for both. We also have the goal that the skateboard should be good for packing or taking places, and helpful for getting from place to place quickly. This is why ensuring portability and reducing travel time are the same for both groups. Skateboard hobbyists may want a more extreme board than commuters. This is why control direction, control speed, and increase and decrease velocity will be different functions for both groups. The bottom table classifies parts that will be the same for both customer groups, called the platforms, and different for both groups, known as the variants. Because the skateboard hobbyists are going to be using the board in more extreme ways, they will need different types of motors, wheels, deck, and trucks to enable them to go faster and make better turns and have a different feel of the board. The parts in the platforms column will be the same for each board.
We redesigned the skateboard for different customers. We made a deck, wheels, trucks, and motors as a module so it can fit different customers' needs. First, because our primary customers are hobbyists, they need a short and narrow deck to get more flexibility when they want to do stunt performance. And shorter trucks also give the same benefits. And much powerful motor-led hobbyists can have a faster acceleration to get better performance if they need. For our secondary customers, because they are who commute to work or school daily, bigger wheels can provide better cushioning to avoid dangers caused by pits or ups and downs on the road. And wider boards and trucks also have more stability. Because it is used for general commuting, does not require a powerful motor. It is sufficient to use a general motor and can also reduce the price. Here, show the dimension of the redesign part. For secondary customers, wider truck and wider deck, larger wheel size. This is a brief introduction to the redesign. We are Group 13 and this is our interim presentation. Thank you for your patience.